5, 4, 3, 2, 1.
Assalamualaikum and hi everyone. My name is Nur Hayati and my other team members are Hema Malini, Aisha Safia, Dashalini and Nurafifa will explain about a biomedical device that is pacemaker. And some important things about the pacemaker are background, applications, materials and the properties that related with the applications. So I will start explaining about the background. In 1932, Dr. Albert Heyman engineered the first artificial cardiac pacemaker that was powered by a hand crank. Unfortunately, there was some problem, for example, involving the manual procedure, which may lead to serious injury, like the idea of a needle assembly connecting to heart to an external power pack. And then in the 1958, Exning and Ron Elvis invents the first implantable pacemaker. And Arne Larsen was the first patient have implanted pacemaker. They used silicon transistor to generate pulse within a device that was small enough to be placed under the epigastrium under the skin. Since a nickel-cadmium battery powered the pacemaker, the lifespan is limited, and Larsen had received a total of 26 different pacemakers. In the 1960s, Wilson Greatbatch and William Chardick developed an implantable pacemaker that powered by zinc mercuric oxide battery cells. The lithium battery was encapsulated in epoxy to provide a 17-year long battery life, and it can be functioned continuously for more than 4 years without recharging as pacemakers. And then next, in the mid-1960s, Baron Berkowitz invented the demand pacemaker. He designed a pacemaker built with sense amplifier that could detect spontaneous heart activity. Below is the basic principle of the functional pathway of the demand pacemaker. And then next, in the 1972, Wilson Greatbatch used lithium iodine battery in the implantable cardiac pacemaker. The battery lasts for about 10 years, and even today is the power source for many manufacturers of the cardiac pacemaker. And lastly, in the 1980s, steroid-eluting leads were developed to decrease any inflammatory response from the continual use of pacemaker. By reducing inflammation and the potential for scar tissue to form, the efficiency of the pacemaker also improved. So that's all in the part of the timeline or history of the pacemaker. Next, I will pass to Hema Malini to explain about the application of the pacemaker.
Thank you, Yati. Now I'm Hema going to present on applications. First of all, what is the function of the pacemaker? Pacemaker continuously monitors the heart. Then, it also restores normal heartbeat and rhythm. If it detects an abnormal heart rate, for an example, if it's too slow, which is called as bradycardia, or if it's too rapid, it is called as tachycardia, then it sends out electrical impulse to the heart to correct it by stimulation very faster or slower of heart contraction. Last but not least, pacemaker is also used to help the heart chambers beat in sync so that they can pump the blood more efficiently throughout the whole body. Okay, next. Okay, who usually needs this pacemaker? People who have heart problems such as heart rate that's abnormal low or high needs this pacemaker. Then patient with heart muscle problems also need pacemaker. Congenital heart disease, or patient who had a heart attack or heart surgery, patient who had a heart transplant, and also patients who take cardiovascular medications also need heart pacemaker. It all depends on needs and requirements of the patient. Next, types of pacemaker. There are 3 types of pacemaker, which are single chamber, dual chamber and biventricular pacemaker. Single chamber pacemaker is where one lead attaches to the upper or lower heart chamber. From this diagram, we can see that the lead is attached to the right ventricle. Next, dual chamber. Dual chamber uses 2 leads, one for the upper and one for the lower chamber. From this diagram, we can see that One lead is attached to the right atrium while another lead is attached to the right ventricle. These single chamber and dual chamber usually used by patients with atrial fibrillations. Next is biventricular pacemaker. Biventricular pacemaker is also known as CRT, which is cardiac resynchronization therapy. It is used to treat people with arrhythmias, which is advanced after the advanced heart failure. So this biventricular pacemaker uses three leads, one for the upper and two for the lower chambers. So from this diagram we can see that one lead is attached to the right atrium while two leads are attached to the lower chambers, right ventricle and left ventricle. Okay, next is the mechanism of the pacemaker. How does a pacemaker work? First of all, we need to know the elements of the pacemaker. Pacemaker consists of a battery and then computerized generator, which is known as pulse generator, and then it also has wires with sensors at their tips called as electrodes. And first, the pacemaker will be implanted in our chest with one or two or three leads. It depends on patient's needs and requirements. And then these leads will be connected to this device while it is also attached to the heart, and then it will start its function by helping the patient to monitor and control the heartbeat. And then the electrodes will detect our heart's electrical activity and then send data through the wires to the computer to the generator. If the heart rhythm is abnormal, if it's too slow or too rapid, the computer will direct the generator to send the electrical pulse to your heart. And then the pulse travels to the wires to reach our heart. And then the electrical pulse will trigger the heart to pump according to the correct rhythm. This also helps the heart to pump the blood more efficiently throughout the whole body. That's all from me. Next, I'm going to pass it to my friend. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Aisha Jamal and I'll be presenting about the materials that make up a pacemaker. Now, pacemakers are actually made of multiple components and they all need different materials for the construction. But one common factor is that all the materials have to be biocompatible, meaning that it won't cause any issues in the body. It also has to be durable, long-lasting, at least 5 years, non-toxic, and corrosion resistant because the internal environment is rather harsh. Now the outer covering of the pacemaker that protects the internal workings and circuitry is called the casing, and it's made of titanium or titanium alloys because they are corrosion resistant, which is very important. They're also strong, they're light, they're biocompatible, and they're long lasting, usually about 10 years or more. Now, usually it's either pure titanium is used or alloy with 6% aluminium and 4% vanadium. Now the internal workings of the pacemaker that controls the pulse generator and controls the signaling and monitors the heart is the circuitry. And it consists of circuit boards, resistors, capacitors, sensors, and other electronic components, and which are made of silicon usually. And as for the battery that runs the pacemaker, it's usually a lithium iodine compound because it's very long lasting, and also it tends not to lose power fast when it's not in use. It doesn't lose energy. Now, the second part of the pacemaker is the leads, which go from the circuitry and the casing to the body of the pacemaker. They go from there to the heart, and they have an outer covering of polyurethane because it's an insulator. It also protects the internal wires, and it has a lot of good properties because it's very tough, it's very difficult to tear, and it's also flexible and elastic, which means that it's unlikely to break or fracture from the stress of the heartbeats, which is very important because it's going to be in contact with the heart. And it also doesn't cause allergies in the body. and it's biocompatible. One big property of the polyurethane is that it's hemocompatible. It doesn't form blood clots. When it's in contact with the blood, it doesn't create blood clots, which would be very dangerous because it could lead to cardiac arrest and the like. Now, the wires themselves are made of MP35N, which is an alloy of nickel, chromium, and cobalt. And it's usually the extra steel or silver is mixed in as well to increase the conductivity of the wires. And MP35N has a lot of positive properties, like it's very tough, it's corrosion resistant again, and it's ductile, which means it's easy. So it's easy to create the wires and pull them into thin wires. Now, the third and last component of the pacemaker would be the electrodes. Now, these are the tips of the leads, and they are usually, they're not covered, they're uncovered, and they make direct contact with the heart. So they have to be highly corrosion resistant and durable because they're in a very harsh environment with no protective covering. Now, the one of the few materials that is actually suitable for this kind of thing is platinum or a platinum iridium alloy, because the iridium increases the hardness of the wire of the tips. And it's usually in a 90 to 10% ratio. And additionally, of course, it's a good conductor of electricity, and it doesn't create allergic reactions in the body. It's also easy to mold or to form into the small components necessary because the tips have to be very small.
Okay, very good evening. My name is Dashalini, and today I'm going to talk about the element platinum, which is used for pacemaker. Okay, so this is the image of the platinum. Okay, so let's talk about the general properties of platinum. Okay, so this is the general property. So PT is platinum. When you see in the periodic table, if you see the symbol PT, which it means platinum. Okay, so the atomic number for platinum is 78, and the electronic configuration is Xe, 4F14, 5D9, and 6S1. And the melting point and boiling point for platinum is 1768.3 and 3825 Celsius. Okay, so platinum is actually solid during room temperature, and the density is 21.45. And platinum's arrangement is actually face-centered cubic. So we will talk about the platinum's arrangement in the following slide. Okay, so now we're going to talk about the properties or the advantages of platinum when building a pacemaker. Okay, so we can see that there are actually a lot of properties. Okay, so the first one, let's talk about a good electrical conductivity, can be fabricated into tiny components. Platinum, okay, then platinum products can be used to facilitate the insertion of catheters, helps reduce the risk that the body will reject the device, inertness within the body, malleable and ductile. Pacemakers contain at least 2 platinum iridium electrodes, and biocompatibility. So this pacemaker actually has 2 platinum electrodes which used to insert in our body. So platinum alloys are commonly used in surgical tools, laboratory utensils, electrical resistant wires, and electrical contact points. So platinum, okay, so for the biocompatibility, so platinum is actually widely used in medical industry for their biocompatibility. It's because it's ideal for temporary and permanent implantation in the body, as sometimes some other materials can cause allergic reactions. Because not all elements from the periodic table we can use it to implant in our body. They might cause some side effect. So far platinum does not cause any side effect or lesser side effect. And biocompatibility is important because entire biological system can become non-functional due to the system toxicity, which is known as the other elements in the periodic table. And platinum also does not corrode easily in our body, because some metals like ferrum and a few metals, they corrode easily. Platinum does not corrode easily, so this can be used in human body, because rust, it can cause an infection in our body. And platinum actually has high electrical conductivity, which makes it an ideal electrode material for devices such as pacemaker. Okay, so platinum is used as implanted devices such as artificial pacemakers. This consists of pulse generator, a small box containing battery and electronic control system that is implanted in the chest wall and one or more leads that run through a large vein into the heart itself. The electrodes on these leads deliver electrical impulse to the heart muscles, like normal pacemakers, their function. So the electrodes which can trigger the heart pulse. In the case of pacemaker, this ensures that the heart beats regularly and at the appropriate pace, which is known as the basic function of the pacemaker. Okay, so the following is, the crystal structure of the platinum. As I said just now, it is known as the face-centered cubic, FCC. So this is the crystal structure. Okay, so these are the properties of the face-centered cubic, which is FCC arrangement are packed as closely together. Atoms occupying 71% of the volume, strongest metallic bond, and corner of the cube has a fraction of an atom with 6 additional full atoms positioned at the center of each cube face. So as we can see in the picture here, each edge has one atom, and the 6 phases in the middle, there is 1 atom. So these are interconnected with each other. So this is known as the face-centered cubic, which is also the crystal structure of the platinum. Thank you.
Next, I will explain about the properties material for titanium. The basic facts about titanium, which is it has 22 numbers of protons in the nucleus. The symbol in the periodic table of element is Ti, which is represent titanium itself, and average mass of atom is 47.867 gram per mole. For the physical properties, titanium has density 4.54 gram per centimeter cubic. The melting point is 1667 degrees Celsius. The boiling point is 3287 degrees Celsius. The crystal structure, it has two, which is HCP, hexagonal closed pair, and BCC, body centered cubic, while the appearance is silvery grey white metallic. Next, I will explain about the crystal structure of titanium. Titanium has two types, which is alpha titanium and beta titanium. For the alpha titanium, the crystal structure is HCP structure is formed when it's crystallized at low temperature. The coordination number is 12 and atomic packing factor is 74%. And the number of atoms per unit cell is 6. While for beta titanium, the crystal structure is BCC structure, which is formed when it crystallizes at high temperature. The coordination number is 8 and atomic packing factor is 68%, and number of atoms per unit cell is 2. For mechanical properties, titanium has several mechanical properties such as strength. Pure titanium has low strength, but then this strength can be improved by alloying the titanium. Titanium is stronger than aluminium but weaker than steel. For the alpha titanium alloy, it has high creep strength and reasonable ductility. For beta titanium alloy, it has heavier, stronger, and less ductile properties. But when we combine this alpha titanium alloy and beta titanium alloy, it will produce good strength ductility. For the tensile strength for titanium, it has a moderate, which is 220 megapascal. We move to chemical properties. It has several chemical properties, which is reactivity, affinity with oxygen, and corrosive resistance. For the reactivity, the titanium is highly reactivity with a variety of elements, such as oxygen, nitrogen, and hydrogen, can cause titanium to become more brittle. Affinity or with oxygen are very high, and the titanium that contain oxygen exposed to the environment will develop oxide films which stable and inert. Corrosive resistance for titanium is excellent, and it good corrosive resistant to salt water, acids, natural water, and chemical, hence used in various biomedical applications such as pacemaker. That's all from us. Thank you.